do a maximum warp race between all the major series Star Trek ships. I realized that I didn't really have a good understanding of just how fast each ship was going. So the Enterprise D goes warp 9.6 and the Voyager goes warp 9.975. And I guess the Voyager is faster, but how much faster? It's really hard to picture this stuff, so I put together some comparisons. We'll be comparing the speed of light, which is warp 1. Next comes the NX-01 Enterprise, which has a maximum warp speed of 5.2, which translates roughly to 140 times the speed of light. Then we have the 1701 Enterprise at warp 8, 512 times the speed of light. Skipping ahead to the next generation, the Enterprise D. Now TNG uses a new warp speed scale. At this scale, its maximum warp speed of 9.6 translates to 1,909 times the speed of light. Deep Space Nine's Defiant has a Class 7 warp drive, which is rated for warp 9.5, exceptionally powerful for a ship its size, but slightly slower than the Enterprise D, clocking in at 1,841 times the speed of light. The Voyager represents a significant technological leap in warp speeds. Its Class 9 warp drive propels it to warp 9.975, which is 4,354 times the speed of light. And finally, let's look at the Enterprise E. There's no solid specs on its maximum warp speed. Some say warp 9.7, some say warp 9.985, and some say warp 9.995. Warp 9.7 felt a little slow to me, and 9.995 seems a little fast, so let's go with 9.985. Now, I know there are plenty of examples of these ships going considerably faster than their supposed maximum warp speeds, but I'm not going to deal with anomalies or alien-enhanced engines or how fast the ship can theoretically go, but with significant damage or danger to the ship. I'm going for its maximum warp speed as it would appear in the manual for each ship. So let's come up with a test here. I've chosen to race these ships from Earth's orbit to the edge of interstellar space. That's roughly 123 astronomical units, 123 times the distance between Earth and the Sun. That's some 11.4 billion miles or 18.3 billion kilometers. So the first line is Earth's orbit, and the last line is the beginning of interstellar space. And here are the orbits of the gas giants in our solar system for reference. The ships won't be to scale, of course, but their speeds will play out in real time. Ready? Engage. The Enterprise D and Voyager tear through the course, leaving all the other ships in the dust. But the Enterprise D and the Defiant are still going pretty dang fast compared to the 1701 and the NX-01. Now, when I first ran this test, I was thinking, man, these ships aren't really that fast, are they? But looking at light there, it's barely 5 million miles into the journey. But remember, that's also light speed. Light is crazy fast. And even the NX-01, which looks like it's barely moving, is going over 100 times as fast. Still, the NX-01 and the 1701 are taking a while. They would take roughly 7 minutes and 2 minutes respectively to finish. Light would take 17 hours to make this journey. Now, I don't think we got a really good look at the NX-01 and the 1701, so I set up a test just for them. We're going to race from Earth to Jupiter with Light, the NX-01, the NCC 1701, and, well, we'll throw in the Enterprise D for fun. Engage. The NX still feels a little slow here. Just goes to show what 100 years of warp drive development can do. And there's our little beam of light still struggling to keep up. It would take light over 40 minutes to make this journey. Well, that's it for now. Let me know if there are other comparisons you'd like me to make, and also let me know if I've missed anything or made any mistakes. And make sure to ask if you want clarification on my methods. Thanks for watching, liking, commenting, and sharing this video with your friends. And I'll see you next time. The Traveler, wormholes, transwarp, spore drive. In many cases, Star Trek vessels go really far, really fast. And I was curious to see how these different methods of transportation stacked up against one another. Basically, I'm going to see how fast these ships go at the absolute fastest speeds they've ever achieved. The original Enterprise goes pretty fast on a number of occasions. For instance, it achieved speeds so mind-boggling that it actually went backward in time. But the mechanisms here are uncertain, and the actual speeds attained are unknown. So we'll have to look at something more measurable. Utilizing an interphasic rift in the Tholian web, the Enterprise was able to travel 2.72 parsecs, or 8.87 light years, in approximately 8 seconds. That's close to 35 million times the speed of light. The Enterprise D, with the help of a mysterious being known as the Traveler, managed to travel at insane speeds. Geordi claims that the ship moved beyond warp 10, but considering that the warp 10 barrier wasn't broken for another 8 years, I'll use the number provided in the TNG technical manual of warp 9.99999999996, or over 2.8 trillion times the speed of light. Next comes the USS Defiant, or really any ship to travel into the Bajoran wormhole. But for the sake of illustration, let's look at the Defiant, which isn't actually a very fast ship. Its max speed is actually rated lower than the Enterprise D, and on its own, it never really exceeds these speeds. But as a method of travel, the Bajoran wormhole is blisteringly fast, covering about 70,000 light years in mere seconds. There's no canonical data for how long it actually takes to cross the wormhole. Sometimes it feels instantaneous, and other times where the editing feels more real time, it's closer to 30 seconds. But that certainly varies. Assuming that they're all canonical and the speed of passing through the wormhole varies, we're looking at an average of about 5 seconds, or around 442 billion times the speed of light. Next comes USS Voyager. We'll talk about both quantum slipstream and transwarp here. First, quantum slipstream. The USS Voyager successfully used quantum slipstream technology for a full hour before deciding the risks posed were too great. In that time, Voyager traveled 300 light years, roughly 2.6 million times the speed of light, which is over 500 times faster than Voyager's normal top speed. Next is transwarp. On a few occasions, using Borg technology, the Starship Voyager was capable of achieving transwarp speeds. We actually don't have a really good benchmark for how fast transwarp is, but in TNG's Descent, we're told that Borg transwarp conduits are at least 20 times faster than our maximum warp. This would make transwarp some 49,000 times the speed of light, but later, when the Enterprise uses the conduit intentionally, they travel 65 light years in about 9 seconds. This makes transwarp roughly 228 million times the speed of light. But later still, when Voyager uses the Borg transwarp network to travel what appears to be about 40,000 light years, they make the journey in at least 4 minutes, 24 seconds, which translates to over 4.5 billion times the speed of light. The Borg transwarp conduits are described as letting a ship reach anywhere in the galaxy within minutes. The other times, like 49,000 times the speed of light, or even 228 million times the speed of light, aren't fast enough to be described in that way, which gives a lot of credibility to our speed of 4.5 billion times the speed of light for transwarp. That's the number we'll use. And of course, Star Trek Voyager also gave us warp 10, infinite velocity. At infinite velocity, a vessel occupies every point in the known universe and can theoretically appear at any one of those points instantly. This technology, of course, had some unpleasant side effects, but it was achieved by a shuttlecraft, no less. And that brings us finally to Discovery. The USS Discovery employs a very different sort of faster-than-light technology, and it actually sounds an awful lot like a naturally occurring organic transwarp conduit network. Utilizing this network of mycelial spores, the Discovery's sister ship, the Glenn, was capable of using this technology to jump 90 light years and back in 1.3 seconds. That's a 180 light year round trip, which means we're dealing with equivalent speeds of close to 4.4 billion times the speed of light. So those are the ships we're looking at. Let's arrange them slowest to fastest. Voyager traveling with quantum slipstream at 2.6 million times the speed of light. The original Enterprise utilizing an interspatial rift at 35 million times the speed of light. The Discovery traveling with spore drive at 4.4 billion times the speed of light. The Voyager using a Borg transwarp conduit at 4.5 billion times the speed of light. Next, we have the Bajoran wormhole at 442 billion times the speed of light. Then the Enterprise D using the Traveler at 2.8 trillion times the speed of light. And finally, the shuttlecraft Cochrane going infinitely fast. So let's see a race between these different propulsion methods. Here we have a scale of 5,000 light years, and we'll see how far each method can get in 10 seconds, or how soon they cross the finish line. Engage. Alright, so the Traveler and the Bajoran wormhole and infinite velocity really steal the show here. So let's zoom in and get a better look at the slower end of insanely fast. This scale is only 15 light years. Engage. And now, one final test, a 70,000 light year race. Transwarp versus the Bajoran wormhole versus the Traveler versus Warp 10, with a cutoff of 10 seconds.
Engage.
Transwarp looks pretty slow here, but it would still take Voyager only 8 minutes to make the journey. Just think if Voyager had access to this from the beginning of their journey. Getting home in under 10 minutes wouldn't have made for a very interesting series. I hope that was an interesting journey. It was a lot of fun actually figuring out how fast each of these methods of travel were and how fast they were relative to one another. Let me know what you thought, and let me know what I might have missed or what forms of propulsion I might have forgotten. I'd like to give a special shout out to Sam Calkins over at Trek Yards for his fantastic custom animation of the Voyager at Transwarp. You can see a lot of cool renders and starship analysis over at Trek Yards. I'll link to their channel in the description. Thank you all for liking and commenting and sharing this video with your friends, and I'll see you next time.